Today our goal will be to be able to determine the validity and possible bias in statistical representations. So what we're really looking at was we're looking at how statistics are represented in the media and any of the possible biases in those representations. So validity and bias. So the first thing we're going to look at is a thing called misleading graphs. And this is something that you'll see in newspapers, magazines, and we just want to talk about how they mislead us. Okay, the first way that they can mislead us is the scales are distorted. And the few different ways that they can distort the scales on the axes is, first of all, they might not start at zero. Each square or tick represents either a very small or a very large number, and then that skews what the results. The other way that graphs can mislead is the labels are missing or they're misleading, and we'll look at some examples of that. Another thing is the samples used to obtain the data do not necessarily represent the whole population that they're claiming that they will. So let's take a look at the graphs that you have in front of you. Okay. Um, First of all, let's take a look. These all represent the exact same data. Okay, so it's the same data displayed in three different ways. Now, if we look at the first way, we notice we go January, February, March, April. We notice that this says that this is 7,900. Okay, so we have no indication of a scale on the left hand side, so our independent scale. And if you look, this is 17. This is another almost 1,000 more. And if I take that tick and I put it here, and I'm going to clone it and put that on top of it, that should be a 2,000 difference. And is it a 2,000 difference? Well, just hold on, see if we can get over a little bit more. Well, from 87 to 1170, so we're looking at more than that actually. So this is about 1,000. This is says 2,000, but let's take a look here. Between 87 and 11.7, that's almost 3,000 difference. Actually, it is 3,000 difference. Okay, but it's not represented that way. And the same thing here. There's a little less than 1,000 difference between these two numbers. However, if I use the same tick that was shown here, it's not. So something's gone on here on the vertical axes that we really don't know. So it misrepresents the numbers that they're showing us. Now, if we look at the next one, maybe a little bit better in the sense that this time we do have numbers here. But let's take a look. The distance from here to here is supposed to be 7,000. So I'm just going, oops, sorry. Just hold on a sec. Let's actually take a look at that and let's move it. So that's supposed to be 7,000. So that would mean that this distance here is supposed to be 7,000. So 7,000 and 7,000 would be 14. Obviously, that's not working, right? Because up to the top is only 12,000. So again, the distance between 0 and 7,000, the scale there is not correct. Okay, so we have that problem on that one. And let's take a look at the next one. The next one, let's look at the scale of it. So again, let's go from here to here is supposed to be 5,000. Let's see if that's the case. If I take it and put it here, oh, that appears 10,000, 15,000. So that's pretty good. So the problem on this graph isn't the scale here. So what is the problem on this graph? Well, this one goes January, February, March, April, January, February, March, April. This one is backwards, April, March, February, January. Now, why would someone want to do that? Well, when I look at this one, I can see that I'm slowly going down. This one, I see a greater decrease. But when I look at this one, for instance, it is showing an increase. So usually what happens when we see these types of graphs in the media, we look at them very quickly. And if I, for instance, if I was looking at the difference between B and C, I would say this one's decreasing, this one's increasing. However, that is not the case for C is actually decreasing as well. So just a few different things that we're going to put down here just so that we can remember in the future when we look back at our notes. So the problem with A was that we know that our scale is missing. We also know that what they are showing us even here, even though they've given us the numbers, it misrepresents the numbers because the scale between the bars is inaccurate. And that's probably why they have the scale missing also on the vertical part. Now, if we looked at this one here, we know that this scale is wrong. Even though they've given us a scale, the scale is incorrect. The scale on the vertical axis is incorrect. And if we look at the last one, they've done a reverse order on the x-axis, on the horizontal axis. The horizontal, oops, spelled that wrong, missing a letter. The horizontal axis has been reversed. Now, did they do this on purpose? You bet they did this on purpose, okay? So it's not like they made a mistake. It was purposely done so that when the viewer first looks at it, they see one thing rather than another. Now, if you look at what's remaining here, actually what's gone on here is this is the actual data. So this is the data that was used to get these three graphs. And what I'm going to show you here is maybe a better way to show, maybe not. You can see that also what's missing on this one is I'm starting at 7,000. But if I'm just want to look at this, it's maybe a better representation or maybe not quite because it's not starting at 0. But you can see that there's quite a decline in between here. Okay, so let's go on to the next page. Okay, so identifying sample bias. Okay, so how they got the information. So first of all, does the sample represent the whole population? Is it a random sample? How was the survey conducted? Okay, so what we're looking at here is often how the sample was obtained is not given to the consumers. Okay, they don't tell us how the data was collected. They just tell us these are the results. So when they're talking about is it random, it means if I'm interested in how many people smoke, for instance, at Mitchell District High School, obviously I'm not going to stand by the doors that lead out to the smoking pit. Because if I do that, the chances are that it's not that I'm going to get all the smokers and very few that are not smoking because those that don't smoke don't go out that door. So it's not a random sample. Okay, so let's take a look at our first example. It says a researcher went to an upscale mall and surveyed shoppers to determine how much they spent on Valentine's gifts. After a day at the mall, the researcher concluded, on average, Canadian men spend $75 and women spend $92. So let's take a look. What is missing from this survey? Well, first of all, they're making a statement about all Canadian men. Okay, so, and women. So the thing is, we're talking about an upscale mall. Should they be in an upscale mall? Maybe, maybe not. An upscale mall usually means that the people have more income to spend. So therefore, maybe that isn't a good place to talk about all Canadian men and women. So one of the problems with this is it is an upscale mall. And also, we know that means that implies then people have more money to spend. Not necessarily, but people have more money to spend because it is an upscale. Okay, suggest a more accurate way of conducting the survey. Well, they maybe need to look at a few different locations, right? Just doing it in one mall is not necessarily a good thing. Uh, collect from more than one location. Now, another problem is too, like we're saying that men spend 75 and women spend 92. We don't know what kind of stores we're looking at either. Maybe there are very few men's stores in this upscale mall. Therefore, again, we're depleting where the women can spend that money. Okay, so that's just a couple different examples of what you have to be a little bit more cautious of. Now, the second part of the video is going to look at a couple more examples, and then you can have a chance to kind of decipher some statistical information yourself.